So guys, let's wait. I think I am getting more requests, so let's wait for 2 more minutes and then we will start. I hope my screen is visible to you, right? You can text it in chat so I can see. So shall we start? Oh,
Yes, sir.
okay. So it's better if we can able to chat. This is I'm getting too loud voice from your end, so maybe it's better that because there might be some disturbances from your end, so it's better that you always try to chat so that I can answer all of your questions, so that would be easy for me and other people as well. So let me stop this thing at 6:05. Then we can start the class. So sorry, sorry guys. So I can't you know leave some people, and from the next class onwards we will be starting sharply at 6 o'clock. Okay, I think we are good to go. So shall we start? So yes, Sajal. Okay, let me start. So, good evening, everyone. This is Venkata Sai Charan, and I'm a PhD scholar at the Department of Computer Science and Engineering. So, this is first tutorial session for NPTEL class problem solving through algorithms and C programming. Basically the thing is like, sorry for the interruption. So I request everyone to join at sharply at before 6 o'clock from the next class onwards, because it will be tough to add people every time, whenever we are in the class. So let me come back. So the broad idea of having this tutorial session is that be- this course is offered by Professor Anupam Basu several times, and maybe no, NPTEL team has done a survey, and they came to know that there are some gaps in between what Professor Basu is teaching, and sometimes some TAs and other for the other courses also the TAs are not available, and the course is not they are not able to interact much with the professors or TAs to clarify their doubts. So NPTEL came up with this idea that the Prime Minister research fellows from every institute, probably from IITs and NITs. Sorry. So I kindly request you to mute the audio. So the thing is that so they came up with this thought that all PMRF candidates, Prime Minister Research Fellows from IITs and NITs, has to take a tutorial classes for the students, at least once in a week or something, so that it will be better for the learners. So this is the high level idea behind this tutorial class. So we will be having the same meeting, recurrent meeting on the same time, with the same URL, so you can join. So every Tuesday it's from 6 p.m. to 7 p.m. So what we will do in this class is that I will just give a brief idea. So what we will try to do is I will just briefly go through whatever the concept that professor has offered in this week, and then I will try to give some glimpse. So what is the idea behind all these things, and then we will try to solve some quizzes which are there, and so it will be better for you to understand the concept, and it will be helpful for you to approach the assignments as well. So then finally there will be Q&A session, so that you can post your questions through chat, or it will be better in chat, I guess. So you can post your questions and I can take your questions, and we will try to solve them together, so that it's a so that the other guys in the group also can able to learn. So this is the high level agenda for this whole session is about. So coming to the class 1, I think this is the course layout. So I think we are in week 1, and recently I got to know that week 2 lectures have been released. So we will try to cover up week 1 and week 0 in this class. So I will try to give a basic intro about what is algorithm and how you represent the algorithms with different formats, like how do you write pseudocodes and how do you write flowcharts and all this stuff. Then we will take a quick jump into what is how we can able to set up this environment. So I will show it in my MacBook, so it will be more or less the same way. You can use dev C++ in your Windows environment, and you can go for GCC compiler in your Linux environment, and then we will try to understand the basic fundamental things. So before writing any algorithm and before writing any C program, you need to understand what is happening. So basically these C programs are like these are called as high level languages. So what happens if when you compile your program or when you run your program on hard disk? So what are all the things that will happen at the behind the screen when you click run in your when you're trying to run the C program, or when you're trying to compile the C program? We will look into that in a brief in this class as well. Then we will try to touch some scratch some basics about variables and how do you declare the variables and assign the value to it. So then I hope we will then after that we will take a short quiz, and then we will try to take I will try to take your questions as well. So this is the high level agenda for today's class. I hope everybody is okay with it. So I will try to make this class interactive as possible. So please try to post your questions in Google Chat so that I can go in between and try to answer them. So I hope everything is okay. So if you have any queries, you can ping it in chat, or otherwise we can go ahead. So I will wait for 1 minute to see whether any comments are coming from your end. Otherwise we can start. So shall we start? Oh my god. Okay. Okay. Sure. Okay. I think we are good to go. Let's jump into the class. So basically, it is very interesting thing. So algorithms are very beautiful things that as a computer scientist or a computer researcher. Uh, so let's start with very basic fundamental question. So what is algorithm? So if you go by any book or standard book, you can say that there is a set of rules that to be followed for a calculations or other problem solving operation. So oh my god, sorry for this interruption. So basically this is the definitions that they have quoted in the book, but according to me, if you ask, so what is the basic what do you mean by algorithm, I can say that the step by step process to solve a particular problem. So these algorithms are very useful in day to day life. So actually I personally feel that you can call this thing, let's say if, I don't know how many of you are from computer science. So why we call this as computer science, so why not computer education, is because of the involvement of algorithms in this particular thing. So whatever we do in this computer, there is a beautiful algorithms that are written by various programmers that are running in behind. Let's say if you are trying to run some program in your CPU, there will be scheduling algorithms that are running under OS, or if you're trying to connect to some router, or you're trying to send any packets, then we have routing algorithms like Digistra, and there are internal gateway routers and external gateway routers, and the kernel. So kernel itself has a beautiful algorithms to process various things and files. So basically uh, there are many places, like let's say if we are interacting with this Zoom video call, or Google Chat video call, there will be compression algorithms that are working in the background. So all these things, so everything in real life, what we are seeing is an algorithm. So it's a implementation of algorithm. So the programs are not just like the implementations of algorithms. So this is the high level idea about algorithm. Basically the step by step process to solve a particular problem, so that is called as an algorithm. So coming to the next thing, what what are the characteristics of the algorithm? So what characteristics, let's say if something has to be called as an algorithm, so which one should we call as an algorithm? So there are some 6 characteristics for an algorithm. So the first and fundamental thing is, like, we should have a well defined inputs and well defined outputs. That means the algorithm should know what is the input and what should be the output of that particular algorithm, and it should be clear and unambiguous. So algorithms will never is going to be, I mean, if there is any ambiguity in this algorithm, it is never going to functional in a better way. So that's why algorithm should be written as very clear and unambiguous, and there should be other characteristics as well, like finiteness. So algorithm should terminate after a particular amount of time, that is called as a finiteness. So otherwise, because all these computers are like finite state machines, so they have to halt at a particular place. So that's why it should terminate after a particular time. And the feasibility, so that means the algorithm should be simple, generic, and the practical. So simple means it should be written in a, it should be understandable, and it should be applicable anywhere, and it should be practical. You can say that you can come up, let's say you write an algorithm to break the encryption. You cannot say that I can break the encryption after if you give me some computer which is not available, and which should have this super computational power and all this stuff. So it should be practical in the sense, and language independent. So this is very most important part. So whatever the code or algorithm which you are trying to design, it should be language independent. That means, let's say you design an algorithm for routers to communicate, let's say in your day-to-day life. So you can't say that this can be implemented only with Python, or this can be implemented only with C, and this can be only implemented with C++. So it should not be the way. So algorithm should be language independent, and anybody, any programmer, any developer can able to really understand or implement such a kind of algorithm irrespective of the language. So that is the algorithm. So now coming to the next thing, how do we represent the algorithm? So this is very important thing to learn as a computer scientist or computer developer, programmer, or whatever it is. So let's say some scientist or some inventor came up with some algorithm that it will solve a particular problem. So how do you represent it in a real world? So this is very much important. So there are basically broadly two way of representing algorithms. So first is flowcharts, and the second one is pseudocode. Now we will look into the flowcharts very briefly, and then we will go to the pseudocode. So basically flowcharts are very simple. So it will explain the steps from one flow to another flow, like there are different shapes to represent what is happening at a particular moment, and the flow will start, and it will take some data, and it will do some functionalities, and then it will take some decision based on the data or the functions, and then it will finally halt. So how to represent this thing, flowchart, is very typical. So this is very easy to understand. So start and end with start and end will be looking like this blue color symbols, and if we have this parallelogram symbol for data representation, then we have this square representing or rectangle representing the function, and then whenever you want to take the decision, so that will be given represented with diamond symbol. So then the flow will change, like from one direction. So what happens if it is a true, what happens if it is a false? So that kind of decisions is made at this decision making symbol, and finally algorithm will halt at particular level. So let's say for making a simple tea, so it is very easy. Let's start. First we initially pour water into the kettle, and then we will boil the water, boiling water. So water is a data, and boiling water is a function. So you can I hope you are able to differentiate between two. So this is data and this is function. Then you add leaves into the kettle, and then you will try to boil it and pour some tea into the cup and milk. Then if the sugar is needed based on the person, that is a decision making. So whether you want the sugar or not. So here you can use the diamond symbol. So if it is a yes, then you can add the sugar substance into it, and then you will do the function stirring, and then the tea is ready. Otherwise, if you don't need any sugar, if the decision making stumps or decision making things will alter the flow of an algorithm. So if any decision making is happening at a particular algorithm or something, there are two flows. What happens if it is a true case, what happens if it is a false case? So all these things you will come to know in detail when we are going through this C programming, writing the C programming. So then finally, that when the tea is ready, you can stop the process. So it is finite, it is easily understandable, and irrespective of the language or various other things, so it is common and it will be understandable for everyone. So this is how algorithm will look like in a flowchart representation. And this is also the similar example, like for what should I eat on Sunday. So I think you are able to I mean, you got it right, I guess. So I don't need to explain it again. So would you like me to explain through the second one as well, guys? No. uh, Okay, cool. So now we will look into the another way of representing the algorithm, that is called as pseudocode. So this is mostly followed in corporate environments where the architect or somebody will have something in their mind and they will translate that thing to the developer using this pseudocode representation. The pseudocode means they will high level. In a high level, they will say that what need to happen. For example, let's say if you want to write a program to find out whether the number is prime or not. So this is how the pseudocode will look like. So you can mention the input as n. That means this is what we are going to expect for this algorithm. So the input will be n, that means the number. So whether so what we will do, so the basic logic of this prime number is the number should be divisible by 1 and itself, not with any other thing, right? So if it is divisible by 2, 3, 4 or anyone else, then you will not say that one as a prime number, right? So this logic will this loop, so we will look into these loops and all in the further lectures, maybe in the week 3 or week 4. So for now, what it is like, if the number is divisible by 1 in itself, we can say that it's a prime number. Otherwise we can say it's a non-prime number. And you can write this if loops and all this stuff, and finally the output will be the answer, so whether it's a prime number or not. So this is how the pseudocode will be represented. So there are several interesting algorithms in the real time scenarios, like usually we use Dijistra's algorithm that is used to find out the shortest path between two cities or two nodes in a graph. So there are so many case studies are happening. So I would like to show some example. So let's say this is how the typical Dijistra's algorithm will look like. Let's say it will explore the entire space, and researchers recently, some of the researchers like Saket Gupte, he came up with this algorithm called A star search, so which is a heuristic search algorithm. So if you see the Dijistra's algorithm, it will search for lot of space. And if you see the A star search, so he has optimized this Dijistra's algorithm by adding the heuristics. So you don't need to learn about what is heuristics and how it will be useful in the machine learning, all this stuff. So that is not the part of this class. I just want to show you that how the algorithms will be implemented in the real time. Let's say from Bangalore, if you want to reach to the New Delhi, what is the shortest path? So Dijistra's algorithm explored all this stuff and it showed that this is the shortest path. But if you see the A star algorithm, it was just exploring this part and it was showing this is the shortest path. So the computational cost and the space that the algorithm need to explore has to be reduced drastically. So this is how algorithms will be implemented in the real time, and it has lot of practical use cases. So what we are trying to do is, like in this course, we are trying to scratch the surface of this algorithm. So we will try to learn what is algorithms, and then we will learn how to code these algorithms or program these algorithms by using C programming language. So this is the broad idea of this course. and I think we will try to learn some basic fundamentals or tools that you need to understand before writing actual programming to implement such kind of algorithm. So we will try to learn about what is variables and how we store the variables, and then how do you operate with the variables, and then we will look into functions and methods, and what is the arrays, and what we are trying to do with the arrays, and how we are going to operate with pointers, and how we are going to allocate the memory and all this stuff. So we will look into that thing. So now I will jump into the thing called how to set up the installation thing. Like it's not just the installation. So if you want to write some C programming, how do you write it in your laptop or your desktop? So what do you want to do? So here what I am showing is that I am working on MacBook. So I will be showing it in this environment. So this will be more or less the same. So you can use dev C++ in case if you are a Windows user, or if you are a Linux user, you can install Ubuntu, and I think GCC is always available with Ubuntu, or otherwise you can use the GCC compiler. So I hope this is okay. So I just want to know how many people are using really Windows. Windows, whoever is using Windows, just type Windows so that I will know what is the ratio of mm, the class. Okay. Okay. Okay, I see. Oh, seems like everybody is using Windows. Okay, cool. Okay. Oh my god. Uh, okay. Okay. I got the broad picture. So everybody is using Windows. So you can what you can do is dev C++. You can download this one. So I think this looks good. So this is how the interface will look like, and you can write the code, and you can compile the code and execute the code. So what I'm showing is that I will set up usually what the developers will do is developers will set up a custom dev environment, and then they try to compile the code from this particular editor. So what I am using is Visual Studio Code. So I think everybody knows Visual Studio Code. So you can download it. So it is open for everyone. So you can download this one, and from this you can write the code. So from this what you can do is, so there are some add-ons for this Visual Studio Code. Let me show you. So where we can go for this, I think it's in the preferences. Yes, preferences and extensions. So you can go and check for these things. So you can install, once you install this Visual Studio Code, you can go and download this C++ extension pack, so that you will get the IntelliSense. That means whatever we are writing in as a code, you will get to know that you will get that intelligence, like the keywords will be highlighted, and it will be much more easy for you guys. So, and you will get a by default terminal or command prompt below this thing, so that you can write something. So what I will just do is I will try to just because I have installed it in my machine. So I will just try to write some hello world program to show you that how to use this Visual Studio Code plus command line together. So let's say you can write. So don't worry about if you at this point if you are not able to understand what this int main is and what is this hash include means and all this stuff, you don't need to worry. We will cover it slowly. Don't worry. So we will just write the printf statement to print something onto the console. So let's say hello world, hello guys. Uh, so and let me print that one. So let's say once I'm done with this, I will try to save the file. And so I hope you know this quite well. So we need to change to week. So this is the structure hierarchy you can see. So this is hello world, hello world.c program. So let me delete this one for the time being, so that you will start from scratch. Yes, yes, and hello world.c. So we are good to go. I think we are in week, sorry, week 0. So this hello world.c is in week 0. So now we are in this folder. So you can see that hello world.c. So now how you will compile and execute the program. So how you will compile and execute the program. So for this, what MacBook have is CLang compiler, which is very much similar to GCC compiler. So just the compatibility different things will be there, otherwise it is more or less the same. So what you need to do is CLang. In your case it will be GCC. So CLang hello world.c. So once you have given this, you just need to write -o and what name you should compile this thing. So I can say that hello. So I hope you are able to see that there is no executable file in this folder right now. So once the moment I click the enter, so there is a hello executable is there. So what you just need to do is, if you are a Linux user, you just need to do /hello. So you will see the hello guys printed on your screen. It is more or less the same. So if you are a Windows user, you will get an executable binary. You just need to click on it. You will show it will printed. So mostly this is the high level stuff. So so this is hash include stdio.h is means this is standard input output header file. So if you want to print something into the screen, or if you want to read some value from the user keyboard, so you just need to include this header file. So every program of the C will start execution from the int main, and whatever it do, it will try to execute from this pointer. So now we will just do the another simple operation. So we will try to read some value or hello.
Hello, sir.
uh,
Here in the main function started with the main.
uh,
If it is instead of int, if it is void, what is the difference between it? Void and
So
int?
yeah, very good question. So I think we are in the very initial stage of understanding this thing. So basically, this is called as a return type. So main is a function, and every function has a return type, right? So uh, there are data types for everything. So what kind of value that it should return as a function. Let's say if you define another function, so the function should be written or void. So void means there is nothing it will return. So int means the program will expect that it will return int. So usually what they will do is, like, they will just write return 0. That means it is returning 0 value to this function, which is also valid. So usually if you don't understand all these mnemonics and what is happening, you, for the time being, you can say that just a void main, and so that it will not expect anything returned from this program, and it will directly execute. Okay, I hope I answered your question. So but we will look into that thing in very detail in the next class. Okay.
Yes, sir.
Okay. Okay, cool. So now let's try to print some variable also in this thing. So let's say int. So I think it's better for me to dig into the int in the variable section, so that you will understand it in a very clear way. So I hope you are able to understand what is happening, right? I just need to check. So are you okay? Shall I good to go further?
Yes, yes.
Okay. So you can also comment it in comment section. I am. It will be okay. Varshini. Okay, cool. So so uh, now what we have seen is like we have seen how to compile our first hello world program in this compiler by using whatever the editor may be, whatever the compiler may be. We know how to run a program. So now as a C programmer, you need to understand what is happening. I mean, why this why this C language, C lang hello world dot C hyphen o is giving me this output. So what is happening behind the screen? So now we will try to understand what is how the compilation process of the program will happen. So this is the high level overview of the how the compilation will happen. So let's say if you submit if you have a source code written in .c. So one thing I forgot to mention, so all the files will be having the extension .c for C program, .cpp for C++. So in case if you are using dev C++, they might if you don't save it with .c, they might save it with .cpp, that is C++. So don't get confused. So try to save it with .c file. So now we will try to look into what will happen if you compile the program. So there are several steps. So one is pre-processing, compiling. I mean, preprocessor is there, compiler is there, assembler is there, finally linker will be there. Then you will get the executable. So at each step, what is happening, we will try to look and see. So let's say if you have a C program, then initially after C program, it will be given to the preprocessor. What preprocessor will do is like it will remove all the comments. So I think I have not shown you the comments. So this is how we can say that we can write a comment. So that means, let's say if you want to describe about this method or something, we can say that I am printing hello world. So whatever we write in this comment, it will not displayed, or it will not be considered by the program. It just for the developer's purpose. So let's say if let me recompile this one again. Okay. uh, okay. Oh, it is not allowing void main. For the time being, we will do it as a 0. So we need to learn how to actually see all these warnings and errors, and how to fix those warnings and errors. So we will do that in a later session. So let's say again I have compiled, but let's say this thing is not going to be printed in hello. So let's say /hello. So hello guys, that's it. So whatever I have written here, it will be just like a comment. So it is for the developers, or if it is for the documentation purpose. So this is a single line comment. So if you want to write it in multi-line, you can write that this is multi-line comment. So this will span for I think this will span for several lines. So that means if you want to write so you can say that so this is a multi-line comment. So this is how it should be. So it is more or less same. So whatever we have written, it is not going to print. So what the preprocessor will do is eventually it will remove all the comments from the source program when it takes the C program as a C file as an input, and So we have written another thing called stdio.h, so which is a header file. So it has lot of functions that is running. So we have not defined or declared or whatever it is printf function, but we can see that we have used this function. So from this header file, the programmers has written the actual logic for this printf function. We are just using that function here. So all the code of this particular header file will be included in this particular phase preprocessor. Then the preprocessor, what it will do is like it will generate a it will get rid of all the comments, and it includes the code of that particular header file. Then it will pass the data to the compiler. So what the compiler will do is like it will take that C program and it will represent it to a assembly language, which is called as a intermediate representation. So this will deal with the registers of the memory, R1 R2 registers, and buffer value, heap values, and it will be represented in a assembly language. So this is how the let's say if we write hello world program, this is how it will be converted in the assembly language. So you need to understand what is data segment and code segment, stack segment, and heap segment. So if you are good with microprocessor and microcontroller programming, you will understand what it is. So for the time being, you just need to understand that it will convert the program to some intermediate representation called assembly language. Then what assembler will do is like assembler will take the data, which is an intermediate representation. Then it will try to generate the object file, so which is having with .vo extension. So this is called as a .vo extension. So this is how the object file will look like if you try to open it in any of the command prompt. So this is just like in the binary, that means ones and zeros. So the computer will understand only ones and zeros, right? So finally the assembly code will be converted to ones and zeros in this case. So then once and after converting into object file, what it will do is uh, let's say I have written a program which is having several other functions. Let's say we all are in a company, and I have given you a task to write one function each, so one algorithm each, and then we will compile together to get the output of that particular process or particular code. So you have written, everybody has written some object file in your C program, in C program compiler, and you just gave me all those files. So I just need to call all those functions from the main function of my file. But how the computer will know that this method is there in this particular section. So for the example I will show you. Let's say this is void main, and it is calling some show message which is not there in the scope. So what it will do is like it will get some linker. So the basically the task of linker is to check whether is there any dependent files, or is there any, let's say if any of the function is called from this method, whether the binary of that function is there in another place. So it will try to link all those functions together, and it will try to basically this is the binary of this function, this main.c, and it is calling show.message which is there in another binary. So what it will linker will have is the address of that particular function. So it will try to go to that place, and it will try to add those particular function into this main file, so that it will create a final executable file. So you can call that function and you will get the result as well. So this is how the linker will do. So finally you will get the executable. So whenever you just write the code and compile it, finally you will get the output. So this is the whole logic running behind your just tiny hello world example. So this is the thing. I hope you are able to understand this one. So if you have any queries, then you can ask me, or I can proceed further and try to wrap things off, because we are running out of time. So you have any queries? Okay. So next what I will do is I will try to cover the variables and all this stuff in the next class. But the high level idea of the variable is that you can consider the variable as a class. Let me type. So this is a glass. So variable is a variable is just something like if you want to do some operation or something, so you just need to access some memory. So then this is just like you try to hold something in your thing. Let's say your data is the water and variable is the place. So this is called, this glass, external glass is called as a variable, and this is your data which is there in the real memory. So let's say if your water is data, then your glass will be the variable. It will just hold the data for some particular time, and this is how we typically represent the declaration of the variable. So there are two things you need to understand broadly. One is declaration of the variable and how you define the variable. So declaration means, as I said earlier, it's a data type and the name. So let's say int name, that means it will store the integer value. So if it is a float name, it will store the float value. So this basically, the data type means what is the size of that particular glass in the real, say, real scenario. So whether it's a 1 liter glass or whether it's a 2 liter glass or 500 ml glass, so this will differ, right? So similarly the same thing. So int will allocate 4 bytes or 8 bytes based on your operating system or your environment, or whether it's if you want to save some large values, you can save it in in long variables or float variables, etc. So you can see, you can google it. So what is the data types and what is the ranges of that particular data type. That means in the char variable it will allocate 1 byte. So whenever you define a char variable in your program, so it will allocate 1 byte of memory from your real memory, and the range will be 0 to 128. So you can save, you can say that minus, you can save the values from minus 128 to 127 or 0 to 255, or if it is an integer you can say. So these are rough values, so this will change based on the environment and what is your compiler, whether it's 64-bit or 32-bit and all this stuff. So but this is the high level idea. Now I think we will look into this thing in more detail. I will just try to run some sample program to show you that how to access the variables and declare and define the variables. So let me do week 1 on week 1. Okay, cool. So this is called as variable declaration. You can say that you are saying that I need a variable, I need a class of integer type a and b. So this is the name of that particular variable, whether it's integer or float. So you are defining that I need a c and I need a f. So then defining the variable. So defining the variable means then you are actually initializing the value to that variable. So let's say if you are it is for the example I will show you. So this is the memory in your computer, and you declare a var which is of type int. So it will allocate 4 bytes of memory, and the moment you initialize the var, or this is called as declaration, and if you initialize that value, let's say var equal to 10, that means the value will be stored, the 10 will be stored in this particular memory. So this is called declaration, and this is called an initialization or definition of the variable, defining the variable. So this is the high level thing that you need to understand. So this is a sample program. So it is not necessary that you declare the variable and you define the variable. Let's say if you want to do something like int k equal to 10, so that means you are trying to declare and define the variable at the same go. So every time it's not necessary that you define two variables in this place. So you can do that int p comma q comma r comma s. So all these things will be initialized to something like this. So this is how it will look like. So we will just do some arithmetic operation like int a plus b. That means we are trying to add let's say 24 and 20, and then we will try to do some particular operation on the float. So let's say if you are dealing with the decimal values, you are trying to use the float variable. So what is this percentage d and percentage f? So you don't need to worry about it if you want to. So it is like a decimal integer. You are saying that, you are telling the compiler that I am trying to print a decimal integer which is there at this particular location. So this is how the compiler will interpret this particular line of code. So you just need to do that. I will just run the code for the time being. clang I just need the run dot variable. So don't worry. So this is my previous one. Let me clear clear that one, and clang what is the program? Variable dot c, variables dot c hyphen o variable. So now if I do variable, you will get 44. That means 20 plus 24. So 70 modulo 70 divided by 3 is 23 roughly. So if you want to do that thing, so this is the high level output. So I think we are it's better that we will stop here, and we will take a short quiz now. So what now what this is just like your assignment. So you just need to understand what is happening. So can anyone tell me what is the output of this particular algorithm and what it is trying to do? Anyone? Hello? Anyone is there?
Yes, sir. Yes, sir.
So can you see and tell what is happening? What is the output of this particular algorithm?
Yeah. Basically, it is doing some computation operation, that is addition and division operation.
Yes.
First of all, number from the input is read from the variable
Uh,
x
uh,
10, and
mm-hmm.
is taking data is assigned to the another variable y.
Yes.
Yes, and then y accounting to the computation operation x upon y plus 2y.
Mm.
So here x is the 10, and again it is divisible by the 10
Uh,
plus 2 into y. Again that is a 20. Means 10 divided by 30 will be the y operation.
so no. So you need to. I mean, whatever you interpreted is right, but can you just mute yourself? For 1 minute I am getting a lot of disturbance. So whatever you interpret is right. So there will be another small topic called precedence of the operators that you will see in the next class, I guess. So this is like what it will do, because the divided by is having high precedence. What it will do is like it will do x by y, that means 10 by 10. So because the y value is also 10 here, so 10 by 10 it will do, then it will do the addition operation. So that means 10 by 10 is 1, right? So then it will do the plus operation with 2y. 2y means 2 into 10, that is 20. So that means 21 will be the output for this particular flow chart. So you interpreted more or less right, your intuition is right, but just the issue, you just confused with the precedence of the operator. So I will try to take that thing in the next class. Yeah, very good. So most of the people are giving answers. So Sindhu, Jahid, and Sejal, and good. It prints 21. Yeah, you are true. So now let's look into the some next question. So the second question is, so what is the thing that scans the entire C program and translate that into a machine code? So either it's an interpreter, compiler, program counter, or operating system. What will do that? So I'm expecting your answers from uh, okay, compiler. Good. Vaishnavi. Yes, you're right. Yes, you're right. So yeah, the third question we will do. So what punctuation mark will end the uh, line in C? So what we have seen some program, right? So it's better you answer it in this one. So yeah, semicolon. You are true, right? Semicolon. Yes. So true. Semicolon is the correct answer. Option D. So finally, we will do some things. So how do you write comments in C? So I have shown two things. So I just want to know the multi-line comment. So how do you write multi-line comment? So what you will use? Yes, true, true. So true. Very good. Very good. Yeah. Finally, this is another sample output. So it's another sample algorithm. So given n value is equal to 7, so what does this particular flowchart will print and stop the code? So what it will do? So can anyone guess it? So it is coming here and doing some operation and all this stuff. I think you need to, I just need to make it a little bit big enough so that you can see. I hope you are able to answer. Very good. Who is Aditya Joshi? Yeah, you are absolutely right. So this is going to print the factorial of the number. So that means let's say you try to read the algorithms. You just go through Google and try to read the flowcharts and what they are doing. So initially I equal to 1 and x equal to 1, it was initialized to 1. Then if it is I is less than n, then what it is trying to do is it is trying to increment the I value, and then it is trying to multiply the x with I. That means initially the one initially the value of I is 1. So that means you will get 1 into next iteration. What it will do, it will do again, if the I is less than n, it is going to increment I and x star I. So that 1 into 2 into 3 into 4. So basically it will do the factorial of 7. That means around I guess 5040 is the answer for this particular flow chart. So yeah, you are right. So I think that's all from my end today. So I would like to take some questions from your end if you have any, or otherwise we can wind up the session. So sorry guys, so it became late, little bit late. I guess from the next time onward we will try to wrap it, and I will give you some time for taking your questions and answering. So if you have any queries, you can just go, you just ping me in the group. I can say your name and then you can unmute yourself and ask the question. So that's how it will go.
Sir, can we get the step work?
Whoever is speaking, just mute yourself. I can't. Yeah, sorry, Sachin, yeah, Sachin, your voice is too shaky.
Okay. Yeah. Whether we'll get the stuff of the material which you have shared right now.
Yeah, sure. I will do is I will share you. I will. I will try to. I need to check with this. So
To us while doing a study.
uh, it will be helpful for you, right?
What I observed, this is a line between the gap
Ah,
while it's helpful to us to while doing a study.
okay, okay. Let me do this right away. So I will share a copy which is non-editable. Yeah, I will do that. No worry. Oh. So any questions? You can unmute yourself and ask. Or just do me. Okay, I can't share. let me see. I don't know what happened to this one. Okay. Oh man, so it is taking some time. I would like to share it right away, because I can't share the editing version. So because you might so what I will do is mm, sorry, sharing is okay. Sorry, just give me one more minute. I will share this content with NPTEL team so that they can share it with you. Will that be useful?
Okay, sir.
Or you can just mute yourself. So I will do one thing otherwise. So this is my um, okay, I can't share the thing to everyone. So yeah, okay. Mm, I will do one thing. So maybe from the next class I will give a shareable link at the start of the meeting so that you can see all these things. So will that be okay?
Okay, sir.
Okay. Sorry, I'm having some issue with the sharing thing. So otherwise I would have shared the link right away. Okay. Okay. Okay, viewer. So copy the link. Anyone with the link only view. Okay, that's cool. So let me recheck that one with incognito, because I have to share these things with. Okay, cool. Okay, you can access it from this one right away. You can see the thing. Okay. So any other question? Otherwise we can wind up the session, and we will exactly meet on the next week. That is like I guess it's 9th. Yeah, 9th. 9th is Moharram, right? So you do have any holidays, or is it like normal? I don't think so. So anyway, let's not break it. So let's do it on 9th.
Normal, sir.
Let's do it on 9th. No issues. Huh? Okay.
Yes,
So
sir.
Yes, sir.
Yes, sir.
Yes, sir.
okay. I'm signing off. Thank you once again. Hopefully, we will see you in the next class with some exciting stuff. Probably, we will look into some functions and all this stuff. Okay, that's all in this class. Have a great day. Good night. Bye. So, just join in the same link in the next class as well. Thank you.
Yes, sir. Thank you, sir. Thank you, sir.
Thank you, sir.
Thank you.
Thank you. Thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.